So thank you very much for having me. So I'm Muir. I'm a final year PhD researcher with the Tyndall Centre Marine Research. My supervisors are Andrew Welco, Claire Goff, and Amanda Leah Langton. So thank you very much for coming to this presentation. So it's a little bit different, this presentation. So one of the most critical technologies that we have in the climate change is bioenergy carbon storage, or BECS for short. So I always like to have a little slide explaining what the technology is in all my presentations. So it's basically you take a biomass feedstock, you extract energy from this, and in that process you are creating a CO2 stream from that. And if you capture that and store it geologically in the subsurface where it can no longer interact with the atmosphere, you're creating what's called a negative emission. So as you are decarbonizing all of your sectors around the globe, there are some sectors which are really hard to decarbonize. So there'll be a little residual CO2 that's being produced, which is a positive emission. So you're trying to create these negative emissions to offset these positive emissions to be able to get the net to the net zero. And BECS is currently the best strategy of getting to that. And you'll read it along. There's a new report by the IPCC this morning about mitigation options for the globe, and they say that BECS is one of the best ones. But remember, it's not just forestry, and it's not just energy crops you can use as a biomass feedstock. It's a huge variety you can use. So just a little bit of setup as well. For the UK, we have 4 main locations which we're going to be putting this technology. So there's basically the Scottish cluster from Grangemouth up to Peterhead, and we've got the used to be 2, so off in Keysight and off in the Humber region, as well as the northwest. We're over here. So we've got the high net cluster over here that's going to be soaring offshore here, and then quite the unique one of the South Wales cluster along the south coast of Wales, which they lack a geological storage site which is suitable. So they have to rely on the shipping of CO2 into the northwest and store in their storage site. Next slide. So the modeling that I do, I need to know exactly where the biomass is and how much there is at every location, down to the resolution of the plot of land. So I've built a biomass repository with high spatial resolution data for a variety of feedstocks, such as crop residues, fuel straws, animal residues, manures, slurries, forestry residues, municipal solid waste, sewage, and wastewood, and then use this data to know how to build and simulate these BECS supply chains and optimize where best to place these and how the carbon performance is that. As even within a BECS supply chain, you are constantly battling between the negative emissions that are generated by the supply chain, as well as the positive emissions, and to get a favorable net negative inside the supply chain. So next slide. So I've created a digital twin of the UK's freight network transport network for the UK. So it can move anything around the UK by automatically switching between trucks, tractors, rail, ships, and pipelines using a carbon-based cost matrix. So it's moving all this around by optimizing your CO2 output by transportation. And by using this, plugged in with the biomass data, you're able to pick a location and tell it to find me, say, 0.2 megatons of wheat straw. Tell me how much carbon that's going to cost getting it to my location, as well as how much CO2 is being produced from that location, sending it off to its geological storage site, and how much carbon that's going to cost you, as well as the energy output generated by the facility. So this is our most recent paper. We've got another one in peer review right now, but this model has been created for BECS specifically, but can be repurposed for any technology or any supply chain. So if you're moving something somewhere, this model can optimize that. Next slide, please. So like I said, you can do this for one location. So this is one I chose from Keysight, where I told it to go find me 0.2 megatons of wheat straw, tell me how much carbon it's going to take to get there, and then generate and offshoot that CO2 off into its geological storage site. You can do this for a singular location, or what it's more interesting is you can do it for multiple locations. So what happens if your facility is in the Highlands? What happens if it's in if it's in the middle of London? You're able to generate these for multiple locations, generate heat maps to model their carbon performance to find the most optimal location for specific supply chains. So you can see for this one, the most optimal locations are here, 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 and there. So you're able to put these maps in front of policymakers and NGOs and industry to tell them what's the optimal site for these locations. So next slide. But due to the high spatial resolution of the data, you're able to zoom in. Come back. You're able to zoom in as much as possible as you like. So this is a nice little zoom in for the northwest. You can see the most optimal location is Connors Key. I can never say it right, but so you can really zoom in as much as you like. Next slide. So you can then further this into modeling. So I've modeled 3 supply chains. And your question is, what supply chain do I do for any location? So I've done a municipal solid waste one, a wheat straw one, and a sawmill residue one that's generating some hydrogen. So this map here says, which one do you choose depending on where you are in the UK? So you can see the blacker one here is for wheat straw. This one here you use the municipal solid waste, and the stripy one you use the sawmill residue supply chain. And I've not got time for this, it's only 8 minutes, but you do see these concentrations of areas around areas with high concentrations of biomass supply, as well as your transportation switching locations. These are your rail terminals, your shipping ports that give you a sort of low carbon highway to get your things moving. Next slide. So how much time do I have left?
You've got 3 minutes.
Perfect, I can take the time here. So climate change is going to drastically impact how you're going to run your BEC supply chains for the UK. So I run these, that is an animated map, so I apologize if you do lose me in this, but I run these supply chains through a series of scenarios and see how they impact their carbon performance. So these include your CO2 output, so what happens if there's a call for a much bigger supply chain. So generally, on average, your ABEC supply chain will output 0.4 to 0.8 megatons of CO2 per year, and you store that under the ground. What happens if your hard-to-abate sectors don't decarbonize as much as you can, and you need more negative emissions? We need to do more. How do these carbon performances supply? Is there enough biomass? Is there enough infrastructure to be able to run these sorts of simulations? As well as energy output. What happens if you need bioenergy to upgrade and to generate more energy? Or the CO2 capture rate. So lots of these projects are stated at a specific capture rate. So it ranges from 85 to 99% capture efficiency from the CO2 you put out. But it does stagnate and move around in a facility. So how much impact into your supply chain emissions is there from doing that? As well as your biomass yield. So what happens if one year we have a heat wave that knocks out half of your biomass supply? Can you still run your BEC supply chains for that? How resilient is your system? I'll skip this one because I've gone into more detail about that. But what happens if you're also decarbonizing your transport methods? So what happens if you're introducing a biofuel or a hydrogen-based fuel, or any of the other blendings into your transport system? How more efficient does your system run? And does that change where you ultimately place your facilities? These are done for trucks, rails, and shipping. I can answer away from that. The priority is basically trucks, shipping, then rail on average, but it does vary a lot depending on where you are. As for shipping, it's really valuable to decarbonize here, and not so valuable here. So biomass availability is the one that I've chosen just to zoom in a little bit more on. So you can say this is like, what is the level of competition for your biomass resource? As fossil fuels are transitioning out, there's now a greater demand on your biomass resource that you're running. So the biggest one right now is bioplastics. So what percentage of the total production do you want to kind of cave off into bioenergy index to make sure that you get a somewhat optimally running facility? So you're able to run these calculations through the model using a series of maps all stitched together, and then running some statistical analysis on there to find I nickname it the good enough value, because ideally you want all of the biomass for yourself, but there are other sectors who need the resources. But with this analysis, you're then able to go to policymakers and say, for BECCS and bioenergy, you want for sweet straw, you want between 11, let's call it 12 and 25% of total supply secured for bioenergy, to make sure that you have at least 50% of your potential carbon savings. If you have all the supply, you get 100% potential, but to get at least 50%, you need at least that much supply. I think that's the end of it.